Hello and welcome to my talk, How to Edge Cache GraphQL APIs. My name is Max Stoiber and I am here in beautiful Vienna, Austria, where I grew up and now also live. I am most widely known for having invented a whole bunch of open source projects in the React ecosystem, like styled components, React boilerplate, and a bunch of others. Right now, I am the co-founder of GraphCDN, which is the GraphQL CDN that does basically edge caching and analytics, and we're working on some really cool stuff to help people operate their GraphQL APIs in production. This whole journey started way back in 2018. I was the CTO of a startup that was building a modern take on community forums, mainly for open source projects. So lots of open source projects used us to communicate between each other, but also with their users. And since it was a forum, a lot of it was public, and we got quite a fair amount of traffic, and we were growing pretty rapidly. Unfortunately, I had chosen a not super well supported database that didn't have a large community and wasn't widely used. And so honestly, just wasn't right for our use case. And we ended up having huge database troubles. Essentially, our database servers were on fire. Now, I found this image on Google image search, and I had to put it in because it's way too hilarious. Why would you overlay fire over this rack just like that? Like, the whole image just, anyways, doesn't make any sense. I love it. So our database server was on fire. And of course, we tried all the basic stuff that you can think of, right? We optimized our database queries. We tried to horizontally scale our database. We tried to reduce the amount of database queries we make at all, right? We added indices where necessary. We did all the things that we really needed to do, but our database still honestly couldn't keep up with our traffic, never mind our growth. And so we were kind of in a pickle. And because we were building this sort of modern take on a community forum, our API was super read heavy. We had lots of public data that was constantly being accessed, but honestly rarely changed, right? Once a user posts something to a forum, that post is the same for everyone, and only very rarely do they go in and afterwards and edit it. And so in my head, I was like, caching. This is the perfect use case for caching. And of course, we had caching for our server-side rendered HTML pages, but I wanted to add caching to our GraphQL API. Unfortunately, no pre-built solution existed. None of the sort of current gen CDNs support GraphQL. And so I was kind of stuck building my own terrible, honestly really bad solution internally. I spent a month building a server-side GraphQL cache, but it never really worked and honestly added a ton of complexity to our infrastructure. And the whole time in my head, I was like, why can't I just run a GraphQL client at the edge? Like, why would that be hard? Why would that be difficult, right? Why can't I just do this? Because fundamentally, what GraphQL clients do is they cache GraphQL queries. Now, they do it client-side, right? They do it in the browser. If you're looking at Apollo Client or Relay or Urkel, what they do is they get back the response and they cache it in the browser. And I thought, well, why can't I just take that same logic, that same code, and just run it at the edge, right? Like, why shouldn't that work? Well, let's dive a little bit into how GraphQL clients cache and why, honestly, GraphQL is kind of perfect for caching. If you look at a sort of standard GraphQL query like this one, which queries a post field, passes in an argument, slug GraphQL edge caching, so we're loading that specific post, and then it fetches its ID, title, and of its author, it's also fetching its ID, name, and avatar. The one magic trick that makes GraphQL caching work super well is the __ type name meta field. As the name suggests, that field returns the name of the object's type that you're querying. And you can add it automatically, and that's what GraphQL clients do. They add it automatically to every single object that's in a query. So even if you write this query, once Apollo Client, Relay, or Urkel send that query to your server, it actually looks like this, with the underscore underscore type name added to the query. Why does that matter, and what does it do? Well, once the server has resolved all of this data, they've resolved the post, they've resolved the author, and they've sent it back to the client, this is what actually comes back from the server. Of course, you get the data that you were querying for, the post's ID and title and the author's ID and name, but what you also get is the type name of the object that you're fetching. And in this case, that's essentially telling us that we were querying the post with the ID 5 and the user with the ID 1. And that really is the key to GraphQL caching, this introspectability, where you can figure out what is the object that I'm looking at right now, like what is this thing, makes everything work, literally everything. Because essentially, and this is what GraphQL clients do, they take this whole response of the post with the author and they store it in the cache. And the next time they see that same query come in, they return the same data. Easy. Now, why do we have to tag anything? Well, the tagging is really important for invalidation. And this is really the part where GraphQL becomes super awesome. Because imagine a user does edit a post and they submit an edit post mutation and change the title to something else. And in GraphQL, every single mutation and every single query that you have to sort of resolve the object that you're fetching. And so we're going to fetch the ID and the title that have changed of the post. Again, just like with queries in mutations, you can also add the underscore underscore type name meta field. And you might see where this is going. Because once this is sent to the server and the server processes this mutation and returns back the result of the post with the changed title, what that response looks like is this. Now, what's super interesting is that the GraphQL client here knows that you've submitted a mutation to the server. The server did a bunch of work, and then it came back to the client and returned the post with the ID 5. And so now the GraphQL client can go, hey, wait, I know that the post with the ID 5 has changed. Let me invalidate any cached query result that contains that post. Done. And that's amazing. And that's due to basically, there's two pieces that make that work, right? One is the underscore underscore type name meta field, which essentially just tells the GraphQL client which object it is that it's looking at. And that works super nested, right? So even if we were to submit an edit user mutation, it would invalidate the cached query result, which is super powerful. And the other piece of it is that GraphQL differentiates between queries and mutations. Now, I know that GraphQL is infamous for sending everything as a post request, but they still, within their own query system, they differentiate between a query and a mutation. And that's really what makes GraphQL clients be able to cache so amazingly. Now, this magic invalidation thing has some edge cases, and specifically where the magic really ends is list invalidations. If you imagine a query where we're loading the list of posts, every single post that was posted, its ID and its title, the response might look something like this once the GraphQL client has added the underscore underscore type name field, right? In this case, we only have one post in this list, and that's perfectly fine. It's the post with the ID 5. Now a user goes ahead and they create a new post, and that sends a create post mutation from the client to the server. The server creates the post, which of course gets a new ID, and then returns that new post to the client, which looks something like this. Now, immediately you might realize the problem. None of our cached query results contain the post with the ID 6. That's a brand new post that we haven't seen before, which means the GraphQL client cannot automatically invalidate the posts query that was fetching the list of posts, because according to the tags, nothing has changed in that query. That's sort of the main edge case that people have to manually configure. And the way they do that is with manual invalidation. For example, with the Urkel GraphQL client, which is one of the more popular ones, you have this updates configuration where you get manual access to the cache. And essentially with this code, I'm saying, hey, when the create post mutation is submitted, please invalidate any cached query results that contain query.posts. That query that specific field, that list of posts. And that way, when that mutation comes in, the local cached query will update with the fresh post with the ID 6. Amazing. Everything's working again. Now, what I was talking about here is essentially sort of operation level caching, right? Which means we're taking an entire query and we're caching its entire result. However, most modern GraphQL clients actually do normalized caching. And normalized caching essentially boils down to almost relational caching, right? You're storing the data almost like you're storing it in tables. Not quite, but as a mental model, it works quite well. You're essentially storing it in tables, each object completely separate. If we go back to our original query of the single post with its post and its author, then instead of putting this entire response that we got from the server in the cache, modern GraphQL clients actually split it up, and they cache the data for the post with the ID 5 separately from the user with the ID 1. And that's super powerful, because if a query comes in that loads the user with the ID 1, the GraphQL client can now go, oh, I already have this data in the cache, right? I can just give you this. You don't need to go to the server. Super fast, super nice user experience, works great. It's kind of nice. Now, what you might be wondering here is, but Max, what about the post's author? There's post.author just doesn't exist anymore. And that's because relations or links are stored separately in a separate data structure most of the time. All GraphQL clients do this slightly differently. This is what Urkel does. They store relations in a separate data structure that looks like this, which essentially is just saying, hey, if the post with the slug GraphQL edge caching is queried, then that means the post with the ID 5. If the post with the ID 5's.author is queried, that means the user with the ID 1. And if the user with the ID 1 is queried, that doesn't have any relations, so we're fine on this table, nothing more to resolve. But that way you can sort of store all of these relations separately, and depending on what the query is actually fetching, you can return subsets of data really easily. Now, what all of that boils down to is that GraphQL is awesome for caching. And again, it's these two things. One, the __ type name meta field, and two, the differentiation between query and mutation that make GraphQL super awesome for caching. The introspectability really, really is key. And the sort of strict schema that tells you you're getting exactly this shape of data and it's going to look exactly like this every single time, no matter what happens. Now, if we go back to the original question, can't I just run a GraphQL client at the edge? And by the way, side note, this is a little bit of a pet peeve of mine that I've tried to avoid, which is saying just, because nothing in our world is just, right? And it sort of diminishes how hard some of these problems are. But that's really what I was thinking at the time. Just something that I like to talk about. Be careful with the word just, because really nothing is just. Anyways, the thing that I really want to point out here is the word the edge, because even if you could write this code, how can you actually run it at the edge? Well, the thing we use at GraphCDN is Fastly's compute at edge product. So what that is essentially just Fastly allows you to run code at their 60-ish worldwide edge locations. And you can run your code there, and Fastly takes care of all of the CDN stuff. They take care of networking, they take care of running your code, they take care of pointing it to the right service, and all this kinds of stuff. And so you assign your service a URL, a domain, and then Fastly will just route requests to the nearest data center from your user. You can run some code when the request first passes through you. Then you forward the request to the back end of the user. The response comes back with the data. You can cache that. You can cache that data and then return the response back to the client. And the next time the same query comes in, you can return it directly from the cache. Now, that's in theory how simple it is. But the thing is actually that running this sort of GraphQL cache at the edge comes with some different constraints than running than GraphQL clients have. Because one of the fundamental assumptions that GraphQL clients work with is that if you can access a piece of data that's in the cache, then you can access any piece of data that's in the cache. It's essentially for one user only. They don't deal with authorization, which is very different if you're running a GraphQL cache at the edge. Because if you're running a GraphQL cache at the edge, many users might be going to the same edge location, right? Many users might be fetching the same GraphQL query from my local data center here in Vienna, right? And so suddenly you run into this problem of, okay, maybe just tagging the response with what's in the response isn't enough anymore, because yes, we just got the same query, but it's coming from a completely different user. And can they really fetch that data? They probably don't have access to it, maybe, right? Like, we need to handle that case. And so the way to handle that is essentially to also tag cached responses with whatever authorization token you have. So either that's usually like a bearer token in the authorization header, or a cookie if you're doing browser-based authentication. But you want to tag your GraphQL responses with ideally a hash of this token. And that way, if a different user sends the same query, you don't respond with the same response. Now, in some cases you want that, so you need to have a little bit of configuration that tells the edge location whether a query is meant to be the same for every user or to be cached per user. But in general, it works by tagging the response with the token. The other thing that's a little bit different is the global cache purging. Because again, GraphQL clients can't just have this cache.invalidate API that just works locally and is super synchronous and works super nicely and fast. But that's not the truth of running this distributed edge cache all across the globe. Thankfully, Fastly handles all of that already. And they exposed a super nice API where you can just say, okay, hey, Fastly, I want to please purge this specific surrogate key, which surrogate key is the word that they use for what I was calling tags. Please purge any cached query result that contains this specific tag. And that's really nice, because suddenly that means I can say, okay, look, a mutation just came through a system that changed, again, the post with the ID 5. And I can submit this API request to Fastly that tells Fastly to purge any cached query result that contains the post with the ID 5. Now, Fastly has this gossiping networking thing that honestly I don't really know how it works, but it's freaking amazing because it invalidates any cached query result that contains this surrogate key within 150 milliseconds worldwide, which is mind-blowing to me. Literally, I think the speed of light to go around the world once, if I remember correctly, is about 130 milliseconds. So in almost the time that it takes light to cross the globe once, they've already deleted any cached query result that contains a specific object that I want to purge, which is bonkers. Now, of course, they don't go around the entire globe. They do it both ways, gossiping, right? So they go around both ways. So they really only have to go around half the globe. But either way, it's super fast, which is amazing because that actually enables a lot of nice use cases where you can essentially run this edge cache for all of your users, no matter if they're authenticated or not. That was really everything I learned over the past year of building GraphCDN. GraphQL, again, is super nice for caching. I'm surprised, honestly, nobody's done this as a product before, because GraphQL, with its strict schema, its introspectability, and the differentiation between queries and mutations, makes all of this caching super, super, super nice. I hope you learned a lot about how to edge cache GraphQL APIs. Thank you for having me, and I hope you enjoy the rest of the conference.